Hi everyone. Today we're going to talk about balancing equations. So in the past week we've started to talk about chemical reactions and the fact that particles have to collide in order to react and that they have to collide with enough energy, and we've talked about endothermic versus exothermic. Today we're going to look at the actual equations for those reactions themselves. So first we have to think about what is a chemical reaction. So last semester we talked about chemical changes versus physical changes, and when we talk about a chemical reaction, what we're talking about is anything that undergoes a chemical change. So we're looking at things that are making and breaking chemical bonds and forming new substances. So for example, when you mix together vinegar and baking soda and it gets all bubbly, those bubbles contain a gas, and that gas is a new substance formed from the making and breaking of chemical bonds. Also, if you've got two liquids and you mix them together and all of a sudden you see this solid precipitate into the solution that wasn't there before, that solid is a new substance with new chemical bonds, new properties. Same thing anytime you burn something, or if you're baking something, you're creating a substance with a totally different set of properties. So that's a chemical reaction. Rusting, so if you've got a pan and that iron starts to rust in the pan, that's a chemical reaction. If you've got bananas and over time they start getting these brown spots, those brown spots are different than the yellow banana peel before because of a chemical reaction. When we write out the chemical equation for a reaction, we want to keep in mind a couple of things. So over here on the left, I've got A plus B. Those are my reactants. So we put reactants on the left side of the equation, and we separate multiple reactants with a plus sign. Over here on the right, we've got our products, C and D. So again, separated with a plus sign. And over the course of the reaction, reactants will turn into products. To separate the two sides of the equation, we use an arrow pointing from the reactants to the products. When we think about chemical reactions, we have to think about the law of conservation of mass. So remember that in any chemical reaction, mass is neither created nor destroyed. So you can make and break chemical bonds, but you're not creating or destroying any atoms. So we can think of this in terms of a delicious s'more here. So s'mores are made out of graham crackers, chocolate, and marshmallows, and you squish them all together to make your s'more. Now, if we took the mass of the graham cracker plus the mass of the chocolate plus the mass of the marshmallow, all three of those together should equal the mass of the s'more. And that's true of any chemical reaction. So our reactants here, graham cracker, chocolate, and marshmallow, have to have a mass equal to the mass of our products here. Keeping this in mind, let's look at an actual chemical reaction here. So this is the formation of water from hydrogen and oxygen. So let's look at the molecules first. So over here we've got a hydrogen molecule. Hydrogen is white, and then because I've got this subscript 2 here, I've got 2 hydrogen atoms. Same for the oxygen, so oxygen is red, and there's 2 of them because I've got this subscript 2 here. And then our product, water, is 2 hydrogens and 1 oxygen. So I've got 1 red oxygen and 2 white hydrogens here. Now, in order for the mass of the reactants to equal the mass of the products, turns out that you have to have also another thing be true, and that's that the number of atoms in the reactants have to be equal to the number of atoms in the products. Right, so each atom has its own specific atomic mass. So in order for those masses to be equal, the number of atoms have to be equal. So let's take a look here. So I've got 2 hydrogen atoms on the left side of my equation and 2 hydrogen atoms on the right side of my equation. So far, so good. But if we look at the oxygens, I've got 2 oxygen atoms on the left side of my equation and only 1 on the right side of my equation. So I'm going to need another oxygen over here. Now, I can't just add an oxygen atom by itself. The only thing I can add to the product side is H2O. So I can add another whole molecule of H2O. So that would look like this. Now I've got 2 oxygens to balance out the 2 oxygens over here, but I've got 4 hydrogens, so 1, 2, 3, and 4. Now what I've done is I've thrown my hydrogens out of whack on this side. So now I only have 2 hydrogens here, and I need 4. So I can add another hydrogen molecule to get 4 hydrogens on my reactant side and 4 hydrogens on my product side. Now I have the same number of atoms of everything on both sides of the equation. So to balance my equation here, I'm going to add what are called coefficients. So I've got 2 separate molecules of hydrogen here, 1 molecule of oxygen here, and 2 molecules of water here. So I'm going to put a 2 in front of the hydrogen a 2 in front of the water. And then anytime I've got a coefficient of 1, I just leave that blank. Notice in our chemical equation, we've got two types of numbers. We've got these big numbers to the left of our molecules called the coefficients, and the small numbers down to the right of our molecules called subscripts. Coefficients tell us how many molecules we have for each substance. So this means we've got 2 hydrogen molecules. No coefficient means there's 1 molecule here. And this 2 means that we've got 2 water molecules. The subscripts tell us how many atoms of each type are in each molecule. So this subscript 2 tells us we've got 2 hydrogen atoms per molecule. This 2 means we've got 2 oxygen atoms per molecule. And over here in water, this means we've got 2 hydrogen atoms. And where we don't see a coefficient, again, that's going to mean 1. So I've got 1 oxygen atom in my water molecule. To figure out the total number of atoms that I have, I want to multiply the coefficient times the subscript. So here, if I've got a coefficient of 2 and a subscript of 2, that means that I've got 4 hydrogen atoms. For oxygen, I've got a coefficient of 1 and a subscript of 2, so I've got 2 oxygen atoms. And then over here on the product side for my water, this subscript is only going to apply to the hydrogen and not to the oxygen. So I've got 2 water molecules times 2 hydrogens, so I've got 4 hydrogens total in my water molecules. And then I'm going to take that coefficient 2 times my subscript of 1 by the oxygen, so I've got 2 times 1, or 2 oxygen atoms in my equation here. It's really important when you're balancing chemical equations that you only change the coefficients and that you never change the subscripts. All right, so let's think about what changing the coefficient will do versus changing the subscript. So here, if I write down H2O, if my chemical symbol is H2O, what that means is 1 molecule of water. So no coefficient here means a coefficient of 1. So I've got 1 molecule of water, which is 2 hydrogen atoms and 1 oxygen atom. If I change that coefficient out in front to a 2, that means I have 2 molecules of water. So I have 2 separate molecules here. Each one is a water molecule with 2 hydrogens and 1 oxygen. And so total here I've got 4 hydrogens and 2 oxygens. If I change the subscript instead, now I've got a totally new substance. So H2O2 is not water. So I've changed the subscript here and I've made a totally new substance. So what this would mean is 1 molecule of hydrogen peroxide. So by changing the subscript, you've changed the identity of the substance. So 1 molecule of hydrogen peroxide now has 2 hydrogen atoms and 2 oxygen atoms. It's totally different. Unlike water, you wouldn't want to drink it. Now let's do some examples together of balancing equations. I'm going to do this using different colored beans, but if you've got something in your house like beads or candy, or if you also have beans like I do, or anything that you have where you've got a bunch of them and they're different colors, it might be helpful for you to work along with me as we do this together. So the first reaction that we're going to balance is this one here. So hydrogen plus chlorine forming hydrochloric acid. And I've got a little table here that's going to help me keep track of everything. And I'm going to know that my equation is balanced when I've got the same number of atoms in my reactants that I do in my product. So I want to make sure I've got the same number in both of these boxes here for hydrogen and then for chlorine. All right, and so what I'm going to do first is I'm going to pick a type of bean to represent hydrogen and to represent chlorine, and then I'm actually going to build these molecules here. All right, so I'm going to pick navy beans for hydrogen. These are these little light tan guys, so that's going to be my hydrogen. And then I'm going to use kidney beans for my chlorine. So those are these little red beans here. Okay. Now what I want to do is I'm going to start off by building 1 molecule of each type for hydrogen, chlorine, and then hydrochloric acid here. So notice I've got a subscript 2 for this hydrogen, so I'm going to need to make my molecule with 2 little navy beans there. I'm going to do the same thing with the kidney beans. So it's Cl2, so I'm going to need 2 chlorines to make a chlorine molecule. And then for my product here, HCl, I'm going to want 1 of each. So 1 navy bean and 1 kidney bean to make my hydrochloric acid molecule. All right, and so this is where I'm going to start. Now what I want to do is make sure that I've got the same number of navy beans on both sides and the same number of kidney beans on each side. So you can see here I've got 2 navy beans or 2 hydrogens over here and only 1 over here. So I'm going to need to fix that. So I'm going to need to add another hydrogen to my product side. However, I can't just add a single hydrogen, right? I can't just add a hydrogen by itself. I have to add the whole thing. I can't make a new product. The only product that I can have is HCl. So I'm going to add another HCl molecule here. All right. And now when I added that HCl, not only did I get another hydrogen, I also got another chlorine. So now I can see that I've got 2 hydrogens on my reactant side, 2 hydrogens on my product side. All right, so I'm going to enter that into my table. And if I look at my chlorines, I've got 2 chlorines on my reactant side and 2 chlorines on my product side. Right? And so once everything's equal, when I've got the same number of atoms in my reactants and products, I know that my equation is balanced. So now I just need to fill in my coefficients in my equation. So if I look here, I've got 1 hydrogen molecule, 1 chlorine molecule, and 2 hydrochloric acid molecules. So I'm going to put a 2 as a coefficient here in front of HCl, and my equation is now balanced. All right, so let's try another one together. This time I've got iron plus silver nitrate, forming iron 2 nitrate plus silver. All right, so I've picked navy beans for iron, pinto beans for silver, chickpeas for nitrogen, and then kidney beans for oxygen here. So I've got 1 iron, I've got 1 silver nitrate, silver, nitrogen, and 3 oxygens. If I look at iron 2 nitrate over here, we have to remember that this 2 outside the parentheses applies to everything inside the parentheses. So I've got 1 iron, but I've got 2 nitrogens and 6 oxygens. So 2 nitrogens and 6 oxygens here, and then 1 silver. When I start balancing, I want to just pick something that's easy to notice. So right off the bat, I can see I've only got 1 chickpea over here, but I've got 2 chickpeas on my product side. So that's nitrogen. So I'm going to need another nitrogen over here on my reactant side. And now again, I can't just add a nitrogen by itself because nitrogen is not one of my reactants. I've got to add nitrogen along with the silver and the oxygen. So I've got to add another whole silver nitrate here. All right, and now when I do that, now I have fixed the number of nitrogens to be equal on both sides. And that also fixed the number of oxygens. So now I've got 6 oxygens over here and 6 oxygens over here. So those are balanced. Now the only thing that's not balanced yet are the silver. So now by adding that silver nitrate, I went from 1 silver to 2 silvers. So over here where I only have 1 silver, I need to add 1 more. All right, and now when I count, I can see that I've got 1 iron on both sides, 2 silvers on both sides, 2 nitrogens on both sides, and 6 oxygens on both sides. All right, so everything is the same on the reactant and product side in terms of the number of atoms. And so all I have to do now is fill in my coefficients. So I've got 1 iron, I've got 2 silver nitrates, 1 iron nitrate, and 2 silvers. So I'm going to fill in a 2 in front of the silver nitrate and a 2 in front of the silver here. All right, so now I want you to practice a little bit on your own. So I'm going to have you use this balancing equations PhET here. There'll be a link on the Canvas homepage. There's an introduction part, and then there's a game, and that game has 3 levels. And so I want you to try the introduction, and then I want you to play the game until you score 8 or higher on each of the 3 levels. And then I want you to take a picture that shows the screen with your score and also your beautiful face in the picture. And then I want you to upload that picture to Canvas and submit it there. We will keep practicing balancing equations on Friday.